Just in case you didn't know, NASA landed a rover on Mars the other day called Perseverance. There are more than a few really cool things about this rover, but what caught my attention first was a video feed of it landing on Mars. And this is the first time ever that we have a video feed of a rover landing on Mars. So when I saw this, I thought that I actually might be able to estimate the lander's trajectory. Fortunately, NASA is releasing their raw images for everyone to do research with, allowing anyone to be a Mars researcher. Now, this particular case isn't trivial. Since I don't have a map, I don't have the calibration data, and the video feed is heading directly towards a flat planar object, which is a degenerate case. Fortunately, I've been working on self-calibration and decided to give it a try. So I tried it, and it didn't work very well, but I'll get back to that later. But what did work very well was creating a mosaic from the video feed. What you're seeing now is a mosaic being generated in real time. The blue rectangle is where the current camera view is, and when it gets close to the image border, it will recenter and rescale. This application is a demo that is included with BoofCV, which is a computer vision library. To get this performance, I did need to tweak the settings a bit on the left to make it use more features, because it was tuned for smaller videos than what it is here. The reason 3D reconstruction initially failed is that the current method it uses requires 3D structure. I hope to fix that soon, but as you can see here, everything looks very flat. When you are far away, the difference between the top and bottom of these ridges is insignificant compared to the distance that the rover is, and everything is essentially a flat plane. What I'm doing now is showing you the image features it uses. The way that this algorithm works is that it takes and detects natural features inside the image and then matches them to a model that fits the motion. In this case, a affine model is being used along with surf. This is actually a really simplistic algorithm. It's the sort of thing you might do for a class project. So it can be unstable at times, but in certain cases like this, it actually works pretty well. If you do have a scene that's rich in texture and 3D depth, you can get very high quality results like this. I'm going through and it estimates the lens parameters and extrinsics and does all this. And for 3 images, I think this is really good results. However, for Mars, this is what I got instead. I never actually expected to get a dense 3D point cloud, so when I saw this was a bit surprising. The reason for that is that when you're heading directly towards an object, that is quite literally the worst possible case for generating a stereo point cloud. What you need is be moving tangentially to the object. Instead, what I was hoping for was that maybe it could self-calibrate and I would get a sparse point cloud and then also know what the camera location is. Instead, I got this hellish landscape where Mars appears to be full of very sharp peaks. Well, that's probably not correct, but this still actually worked out relatively well, especially considering the algorithm itself is not supposed to work well with planes. So I'm going to look to fix that weakness, and I'll post an update if I'm actually able to do a reconstruction of the lander's trajectory. That's it for now.